This video is an introduction for Statistical Process Control (SPC), which is a technique in statistical quality control. So briefly, SPC is a technique to test a sample of output to determine if the process is producing items within the pre-selected range. So in the other words, this is a technique to help manager to help company to identify whether the process is under control or out of control. And the main tools we apply in SPC we call the control chart, and we have different types of control charts according to the outputs we pick up. So we have two types of the outputs we can pick up. In general, if we wanted to know whether the quantity is fine, whether the item is quantified or not, we need to analyze whether the characteristics is follow the pre-selected requirements, the pre-selected rules. So what kinds of characteristics we can choose? Like if we want to evaluate the quality, we can choose, like for a physical goods, we can choose like whether the weights or the length or the color is satisfied with the requirements. So for those characteristics we pick up, actually they are the real value, so they are the actual value. So how weight, how length, and what is the color, so we can translate them with a number over there. So this is the actual value, so this is what we call the variable. And for the variable, we have X bar charts and R charts to help monitor the process, whether they are in control or out of control. And for another types of the outputs we can pick up is how many defects. So this is actually a characteristics that are classified as either conforming or not conforming. So either it satisfies the requirements or not satisfy the requirements. So in general, like in most of the situation, the number here, the outputs, if we apply an attributes as PC here, the outputs, the characteristics we pick up is the number of defects. So how many number of the defects if we pick up a sample and the sample has 100 units. So within those 100 units over there, how many defects, and the number of the defects is the outputs we pick up for each sample. So this is the two types. Briefly, if you have a problem, if you want to evaluate, you want to manage it, you want to have an idea whether the process is in control or out of control, think about the characteristics you pick up. The output, if it is the number of defects, which is the number related to either conforming or not conforming, you need to pick up the P chart and C chart. And if it is related to the real value, so its weights or the length, like 1 meter, 2 meter, so those actual value pick up the X bar charts and the R charts. And this is an interpretation for the process control charts. And whatever the control chart you choose, you may meet those situations. So how to interpret the situation, how to interpret your control chart, what kinds of information you can obtain. You can follow the pictures over there. And now we move to how to compute a P chart. This is a attribute control chart. So P chart. In general, for each chart we need to have 3 lines. The upper control limit, the lower control limit, and the average. So if we back to the things here, The black dot here actually are the real value, are the values for the samples, and we have three lines over there. This is the upper control limit. This is the center line, which in general we use the average number as the center line, and we have LCL, which is the lower control limit. So we need to have three numbers over there for any control chart. As a attribute control chart, the P chart, the P bar here actually is the average of the value, the output you pick up. So the P bar here actually the total number of defective units for all samples divided the number of samples. And SP here is the standard deviation. So the standard deviation of these numbers, the number of all the defectives for all the samples you pick up. And this is the P bar, which is the average number. So we can use the number here as the center line. Except for center line, we need another two lines, which is the upper limits and the lower limits. For the upper limits here, the upper control limits, it equals the P bar, which is the average of the number of defective, plus Z times SP, the standard deviation, and LCL, the lower limits, equals P bar minus the Z times SP, the standard deviation. If you have any negative numbers here, just use 0 as the lower limits. And typically, we use Z equal 3, or you can use Z equal 2. So this is depending on what is the confidence here. Z equal 3 gives a 99.7% of confidence that the process is within these limits. So if you pick 2, it is like around 97%. If you pick 2.58 as the value of Z, it should be like 99%. So it depends on what kinds of confidence you want to involved in this control chart to stand for like within those limits. So this is the Z here in general. Typically we choose 3. So this is how all the formulas to help us to have those 3 lines for the samples we have. So if we take a look with an example here. So we have 10 samples over there, and this is the number expected. So for what is this means? The number expected actually is the sample size. So here I want to illustrate two concepts: the number of sample and the sample size. The number of sample is how many sample you pick up, and the sample size is how many units in a sample. So the sample size for this question, according to the table, it should be 300, and the number of sample, it should be 10 because we have 10 samples over there, and for each sample we have 3 units. So this is the sample size 3 units and the number of sample. And then we have another number. This is what we call the number of defects. So in the sample 1, among those 300 units, we have 10, we detect 10 defective, the defects here, and we have 8 in sample 2, 9 in sample 3. So this is a table information including all the information we need. And now we need to find the average, the P bar, which would be the center line here. So what is the number for P bar? The 91 here is the total defects. If we back to here, 91 is the total number of the defective units, the defects for all samples. So we just use 10 plus 8 plus 9 plus 13, 7 until 8, the last sample. So we have 91. And the total units, the total sample units we have is 10. times 300, which is 3000. So this is the P bar. And according to P bar, we can calculate SP, the standard deviation. So we use the P bar times 1 minus P bar divided by 300, and we want the square root. So we have 0.00990. So this is the SP, and according to SP, we will be able to find the limits here. The upper limits will be P bar plus 3 times SP. As I have mentioned, Z typically will pick up 3. It depends on the confidence within the limits. So if you want a higher, then the 3 stands for 99.7%. So this is a very high confidence. If you want a little bit lower, so about like 99%, you can choose 2.58. So it depends on the standard deviation stuff. And the same we can have the lower limits over there. So according to the numbers, we will have the upper limits, the point limits, and the center line over there. The picture in the textbook, they may not show the center line, but in general, we also need like the center line to describe how the control chart trends. And after we have the upper limits, the lower control limits, and what is the sample we should pick up, what is the numbers here. So because we actually, the 0.03 stands for the percentage of the defects for all the sample units. So in the sample 1, instead of 10, we should pick up the 0.03 as the number we should insert to denote the sample 1, because this is the percentage, like the defective percentage in sample 1. So we use 10 divided by 300, and we have the number, and we use 8 divided by the 300, we have 0.02, and the same. So we have all of the numbers over there, and we will be able to plot all the sample numbers in the control chart. This is a P chart, and according to the interpretation, and you will be able to interpret whether the process is good or not. So this is how we have the control chart, the P chart, one of the attribute charts, and you also will able to find another popular attribute chart, which is a C chart. Page 374. There is another examples, and in sums, this is a general process how we create a P chart. First, we need to calculate the sample proportions P for each sample, and then we calculate the average of the sample proportions, and then we calculate the standard deviation, the SP, and the control limits, and plot the individual sample proportions, and then we will have the control limits, and we will have a chart here to tell us whether it is in control or out of control. Except for the attributes, the attribute chart, control chart, we have the variable control chart, which is the X bar and R. So we do not take up the conforming or not conforming number. We do not take up the number of the defective unit as the output. We value the actual values, like for example weights or the length. So we use those actual values to stand for the outputs of the process of the items, and to evaluate whether they are in control or out of control. And what I want to note, what I want to mention actually, is two things you need to keep in mind. So for the sample of the size of the sample for X bar and R chart for the variable measure control chart, the four we typically pick up 4 or 5. So if we think back to the T chart, the sample size is 300 for each sample. But now if we use the variable measurement process control chart, we prefer to keep a small sample size, which is like in general we use 4 or 5. And the number of the samples, the 25 is a good number to for the number of samples. So this is what we have, and the control name is in general we still use d equals 3. So take a look with the control chart here, the X bar and R chart. If we take a look with the numbers, the X bar chart, for X bar chart we have X2 bar. The X2 bar here is the average of the mean of the range of the samples. So which is I always call the X2 bar as the average of average. So X bar here stands for the mean of the sample. Then if we have another bar here, another line above the X, which means we pick up the average of the average, and I will explain later how to calculate the average of average. And we have R bar. The R bar is the average of range. R here actually is the range. So for our chart, we care about the range for each sample. And except for the numbers X bar and R bar, we can compute via the output we pick up. We have another symbols here, which is A2. And the same except for the average of range, we can compute according to the number we connect. We have D4 and D3s. The A2, D4, and D3 can be obtained for the exhibit 13.7, this table, and you can find the table here on page 377. So you don't need to calculate the A2, D3, the value of A2, D3, and D4. You find the numbers according to the sample size. So N here stands for the sample size. So if you have 2 in each sample, then the A2 should be 1.88, and the D3 should be 0, D4 should be 3.27. And if you have, like for another example, if you have 7 units in a sample, the A2 should be 0.42 and D3 should be 0.08 and D4 will be 1.92. So this is how we obtain the value of A2 and D3, D4. And similar, we have the similar process to construct the X bar chart and R chart. So take a look with the examples here. For this number here, we have 25. If I scroll down a little bit, so we have 25 sample. And for each sample, we have 1, 2, 3, 4, 5. We have 5 sample size here. So in each sample, we have 5 units. And what is X2 bar? So the first thing you need to calculate the average for each sample. So for the sample 1, we have 10.60. This is for the unit 1. 10.40 unit 2 in sample 1, and until 10.20. This is the fifth unit in sample 1. So we sum the 5 numbers together. I divide it by 5, so we have 10.22. This is the average number for the values we pick up for sample 1. So we can calculate, we can compute all the other average for other 25 samples. Then what is the X2 bar? The average of average, because the 10.21 actually is the average for the average of this column. So the average of this column is the X2 bar. And what is the range? So how we obtain 0.70? The 0.70 here equals the maximum minus the minimum in sample 1. So the maximum number, the largest number in sample 1 will be 10.60, and the smallest number in sample 1 would be 9.90. So we use 10.60 minus 9.90. We have 0.70. This is the range. The range is we use the largest number minus the minimum number. We want to know the range in the sample 1. So we have 0.70. And for another example, for sample 2, the largest number will be the 10.33, and the smallest number will be 9.98. So we use 10.33 minus 9.98, we obtain 0.35. This is the range for the sample 2, and we can calculate all the ranges for all the 25 samples, and then we have the average of a range. So we sum all the ranges together for 25 samples and divide it by 25. So we have the average of a range as 0.60. And then according to the numbers we have, the average of average is 10.21 we have over there. And the A2, how to find the A2? The A2 is just 0.58. So think about the numbers here. So for this problem, the example, each sample they have 5 units, which means the sample size is 5. So we're back to the table here. When the sample size equal to 5, the A2 will be 0.58, and the D3 will be 0, and the D4 will be 2.11. So we're back here. So we have A2.58 because the sample size is 5 times 0.60, and we have the upper limits for X bar chart, which is 10.56. And we, according the formulas for the no control limits for X bar chart, we have 9.86 as the no control limits. And the D3 equals 0 if the sample size is 5, so we have the no limits for R chart is 0, and we have 2.11 times 0.60, which is 1.27 as the upper control limits for R chart. And according to the numbers over there, we will have the X bar chart and R chart, and the same how to plot the number stands for the samples. If you use the X bar chart, which means the number 2 stands for the sample 1 will be the average of the sample 1. So the average of sample 2, sample 3, so we can connect all the dark points here, and we have the lines over there. And for the range, because this is the R chart, so actually for sample 1, this is a range for sample 1. So way back here, the range should be 0.70. So for sample 1, it should be 0.70 as the number you should be here to stand for the sample 1. So we have all the numbers over there. So this is how we have the control chart. And in general, in sum, all the attribute control chart or the variable control chart, we need to according the formulas to find the numbers for the upper limits and the lower limits and average. So we need to have those numbers over there. And once you have those three numbers, the only thing you left is to put the number to stand for the samples. If you use a X bar chart, then the number stands for the samples should be the average for each sample. If you use the range, the R chart, then the range should be the value you pick up as the sample to denote the samples. If you use P chart, which is the proportion of the defective for each sample, so this is how we denote all the sample numbers in the control chart. And they have the similar process to create a control chart, whether the attribute or the variable. And the last thing I want to introduce is how we can use Excel to draw the control chart here. So for here, we can calculate the numbers, the limits via calculator and according to formulas, and you can like draw the control charts by yourself, by hand, but and also like to introduce another way we can use to draw the control charts. So take a look at the problem, the exercise problem. A company that produce the plastic bottles according to the customer order. So the quality inspector rather needs like 4 bottles for the bottle machine and measures the outside diameter of the bottleneck. So they want to know whether the quality is in control. So they take up the real value, the actual value of the diameter of the bottleneck. And then they have the tables over there. So before we and the problem want to use the R chart and X bar chart to monitor whether the process here to produce the plastic bottle in control or out of control. So take a look at the table here. They pick up like 4 bottles readily, and the 4 bottle here is not the number of sample. Actually, they have 6 sample here, and for each sample they pick up 4 bottles. So the 4 bottle, the 4 is the sample size. And when we want to calculate, when we want to have the limits for R chart and X bar chart, we need to have the number of the A2, D3, D4, and the A2, D3, D4 actually according to the sample size. So remember and make sure, like, because you really need to distinguish what is the number of sample and the sample size. So for this problem, the sample size will be 4 because for each sample it has 4 units. It pick up 4 bottles, so the sample size is 4. And how to find the R chart and X bar chart? As I have mentioned, for each of the control charts, for example, we calculate the R first via the Excel. So here it equals the largest number in sample 1 minus the smallest number in sample 1. So we can use an equation which is the maximum. The MX here equation in Excel stands for they will pick up. If you choose these 4 cells, they will pick up the largest number in these 4 cells. And minus the smallest number, which is the minimum in the same 4. So we have 0.02 as the range for sample 1, and you can calculate, you can find, like, for example, for the sample 1, the largest number will be 0.597, and the smallest number will be 0.577. So we have 0.02. Actually, this just like we use the equations to find the range for the sample 1. And we can use the same way to find the range for sample 2, sample 3. And if you have equation over there, you just need to scroll down the cells and you will have another 5 range for another 5 samples over there. So what is the average range? the average range equals the average. So this is the average equation. The average range. This is the range for sample 1, range for sample 2. So we want to find the average range for all of the 6 samples. So we have the numbers here. So this is the point 0.034 is the average range, which is the R bar. If we back to, it should be the R bar. So for the upper control limits and the lower control limits for this control chart, for these tables we have here, for the upper, it equals D4 times the R bar. R bar is the average of range. So what is the number for D4? Remember that the sample size is 4. So for the D4, it should be 2.28 and D3 should be 0. So we have 2.28 times the R bar, the average of range. So we have 0.07828. If we want into the 3 decimals, so we have 0.078. And this is equals 0 because the D3 is 0 when sample size is 4 and times the average here. So we have the numbers. So for now, we already have the upper limits and we already have the range for each sample. And how to draw the lines? It's very easy. We just need to insert a line chart here. But how to find that one? Because what kinds of data we should involve in this line chart? So for the average, 0.034, this is the average for all of the 6 samples, right? So we just copy and we just paste the values here. And we just scroll down. We choose the same value over the it stands for like the average for all the samples because this is the average considering all the 6 samples, and the same for the upper limits and the lower limits. So we can use a dollar symbol here and it will stable the numbers we have, and when we scroll down it will not move to the next, it will have the exactly same numbers. And this is what we need because for all of the 6 samples here, the upper limit is always 0.078 and the lower limit is always 0, and the average, which is the center line, always 0.034. But the range for each sample are different. So the range for sample 1 is 0.20 and range for sample 2 is 0.043. So we just pick up all of the numbers we want to have and we insert a line chart. And this is not this one, the line chart here. So we have the 2D lines and we pick up that one. And then we have an R chart. So you can change the chart title here. Like this is the R chart because we consider the range, and this is the upper limits, this is the lower limits, this is the center line, the orange line here is the center line, and the blue line here actually stands for each samples. So for sample 1 the range is 0.20, and we have all of things here, and actually you can change what kinds of stuff you want to have, and you can change the different shapes here. So if you change different shapes, and you will have like the series here, actually you can change the name, so you will be able to automatically have the R chart if you have all the numbers for the limits and for the range for each sample. And the same for the R chart. For the R chart, the first thing we need to calculate is X bar, the 1 bar. So the average here equals the average. We still use the average equations. The average for the 4 samples, the 4 units. So for sample 1, the average, the x bar will be 0.587. So this is the average number for all the units we pick up for sample 1. And we can have all other average for other samples. And what is the x2 bar? This is the average of average. So we still use the average equations. The average of the average, so we pick up the average for each sample, and we will have a numbers over there. So the x2 bar actually, we could use the number as the center line. So this is the center line. So we copy and we just use the values, and we can scroll down, and the average, the x2 bar for all the 6 samples actually are the same. And then we need to have the limits. So if we back to the formulas here, for the upper limits, it equals x2 bar plus a2 times the range, the average of range. So the a2, this is what we have already obtained, the average of the average, which is 0.601. And what is the average of range is what we have here, 0.034. This is the average of range. But what is the number of A2? The number of A2 depends on the sample size. The sample size doesn't change, it's still 4. So the A2 will be 0.73. So we have 0.73 as the upper limit we need to plus. We use this one. This is the x2 bar plus 0.7. This is the A2, 0.73 times the average of range, which is 0.034. So we have the upper limits, and we wanted the upper limit is always the upper limit for all the samples. So we just like you can insert the numbers directly, or you can just paste the values. And for the lower limits, it should be the average x2 bar minus a2, which is 0.73, and times the average of range. So we have like the lower limits, so we copy it. We have the numbers over there, and we can circle down, and we will have the lower limits for all the samples. And why we need to scroll down here, actually it's just because we want to have the X bar chart directly via the insert line chart over there. So we choose the numbers we want to have. We want to involve in our X bar charts, and then we insert a line chart here, and we will have another chart over there. So we can still change the numbers here. The X bar chart, and still we can change like the different shapes for each line. This the silver line here is the upper limits, the yellow line here is the low limits. This is the average, the center line, and the blue line here still stands for each sample. We have 6 samples here. The first sample, the average should be 0.587. So this is how we can use the Excel to draw the control chart directly. And this is the example for the attribute, the variable control chart, the R chart, the X bar chart. And you can still like use the Excel to draw the control chart for the attributes like the P chart and the C chart. And the general rules is to find the numbers over there. So for R chart, the range for each sample are different. For X bar chart, the average for each samples are different. But control limits, the upper limits or the lower limits or the center line for all the samples are the same. So if you want to draw the control chart automatically while just insert a line chart here, you need to keep like the same numbers for the limits or the center line for each of the samples, and pick up, choose all the data you need to involved in the control chart, in the line chart, and then you will have the control chart automatically. And basically, for control chart, you need to remember the formulas for each of the control chart, because for each of the control charts we have different formulas to find the limits and to find the center lines and to find the numbers we want to evaluate for samples. So, and the last thing I want to I want to mention is about the differences between the number of sample and the sample size, because when we want to find the right number for A2, D3, D4, we need to have a right number for the sample size. So you need to make sure like not find the number of samples to stand for the sample size. Make a very clear understanding about what's the number of sample, what is sample size, and then you will be able to find the right numbers for A2, D3, D4, and use the right formula. You will have the right numbers for limits and center line. You will have the right R chart, X bar chart, and the same to the P chart and C chart.